Okay, question number 8 from practice paper A, International A-Level P2. Here we have a question which tells us about the plan view of the design for a swimming pool. The shape of the pool is A, B, C, D, E. Back to A again, consisting of a rectangular section here. So this is a rectangle, we know for sure it's a rectangle because it told us. A, B, D, E, joined with a semicircular section, so this is definitely a semicircle. And they've told us some more information. They've told us that given that AE equals 2x, that's marked, ED equals y, that means this must be y as well. Okay, because it's a rectangle, and it means that the radius of this semicircle must be 1x. Okay, so the radius of the semicircle is going to be x, because that's going to be the midpoint of that part. Okay, they also told us that the area of the pool is 250 square meters. So we have to show that the perimeter of the pool is given by this equation. Okay, so now let's get cracking on this. So first of all of these type of questions will be very, very similar in their setup. They normally give you two bits of information about the same problem. In this case, it's about the area and the perimeter. Sometimes it's about the volume and the area. Okay, sometimes it's about, could be anything. Okay, so in this particular case, it's the area and the perimeter that they told us to consider. So we're going to end up with two different equations, one for the area, one for the perimeter. And when we combine them together, we should end up with what they ask us to give. So we've got to think about the area of this whole shape. Now this is a composite shape, which it's like a rectangle, I'm going to call that 1, and a circle, I'll call that 2. So the area of shape 1 is basically just length times width, which is 2 times x times y. And the area of shape 2 is a semicircle. So the area of a circle is pi r squared. So this is going to be pi times r squared. Now the radius is x, so it's pi times x squared, but divided by 2, because it's half the area of a circle. Okay, so we can say then the sum of these two areas will give us 250. So I can say 2xy plus pi x squared over 2 is going to give us 250. Okay, I'm supposed to use the area down in the space to write down here, but I don't want to keep doing this and give us both headaches. All right, now the next thing is to think about the perimeter of the shape. Now the perimeter of the shape is the length of its outline. It doesn't include this line inside, because that's not outside. It's the length of the outline of the shape. Okay, it has to be enclosed. The perimeter encloses the shape. Okay, so if there's any part left open, the sheep will escape. Think about it as if you're trying to build a pen to keep some sheep in. It has to be closed. All right. Now, so you got the length of the outline is 2x plus 2y. You're not going to say another 2x because this is inside the shape. So you got 2x plus 2y. That's this part here. Then you've got the circumference of half a circle. Now the circumference of a circle is given by 2 pi r. Now r is x, and we've got 2 pi r for the whole circle, so it's 1 pi r for half the circle. We only want this part here. So it's plus pi x, like 2 pi x over 2, the 2's will cancel. Okay, so that is now an expression for the perimeter of this shape. Okay, now in what they gave us down here, what you notice is there's no y in there. The y has been eliminated. So basically what we've got to do is we've got to use these two together to eliminate the y. So now once I've got this all written out, I'm going to take these two equations. I'm going to put them down here, and I'm going to combine them together algebraically, and hopefully we'll end up with what we're supposed to end up with. So let me just group that together so it doesn't go. Okay, whoops. That's a bit weird. It went all light. Okay, so there we got the one for the perimeter. Let's bring it down here. Okay, it's come back dark again. Now, so how do I combine these together? Well, okay, I can see that I want to replace this y with what y equals from here. Okay, so what I can do, and I've spotted something to make it even a bit easier, is I can take this expression, and you see how you have a 2y here and I have a 2y there. If I make that 2y the subject of this formula, I can just take this 2y and replace it with what 2y is equal to. So let me make this 2y the subject. So first of all, I've got to get rid of make 2xy equals, get rid of this. So I've got to subtract that from both sides. That's 250 minus pi x squared divided by 2. And I want to get rid of this x, so divide both sides by x. So this will be 250 over x. So it's kind of looking kind of nice there. Alright, and I've got to divide this by x. So basically the x will cancel out. And you'll be left, the x squared over x will just leave me with the x on top. So I'll have pi x over 2. So now I can take the perimeter and replace the 2y with what it's equal to. So I have 2x plus, and now instead of 2y I can write 250 over x minus pi x over 2 and plus pi x, and all we have to do now is add these like terms together. That's like 1 minus a half, so it's like pi x over 2 positive. So therefore we can say perimeter is equal to 2x plus 250 over x plus pi x divided by 2, which is exactly what we had to prove. Okay, so that's how you deal with these type of questions. Okay, you have to basically make two expressions, two equations from the two different bits of information, and normally there's one letter that is eliminated that you'll find in one of the expressions like here. So we made that the subject and then replaced in the other expression that with what it's equal to, and then you've eliminated the letter you don't want and you got what you told. So even if you don't know how to do part A, and even in part B, in part C you should be able to do it still, because they gave you what you need to do to work out the rest, but we'll come to that in a minute. Now part B says explain why x is more than 0 and less than 500 over pi rooted. Now this is a bit of a strange type of question, but basically what we know is x and y are both lengths. Okay, and so they must always be greater than 0, otherwise you won't have anything, right? So we know that x must be greater than 0, so we can say as x and y are lengths, okay, therefore x must be greater than 0 and y must be greater than 0. So this part is justified now, why x is greater than 0. So now let's find out what y is in terms of x. Now y is 250 over x minus pi x, okay, over 2. Well, that's 2y. So we can say that y is going to be 125 over x minus pi x over 4. And y has to be greater than 0, so this has to be greater than 0. So 125 over x, okay, minus pi x over 4 has to be greater than 0. We know that. Okay, so now if I take that, it's quite long-winded for this amount marks. Anyway, 125 over x must be greater than pi x over 4. Now I'm going to multiply both sides by 4 and by x. Now 4 times 125 is 500, so I'll have 500 is greater than pi x squared. Pi x squared. Now why could I multiply by x, because I know x is greater than 0. If you have an inequality and you multiply by an unknown, you can't do that, you have to square it. But now, because I know x is positive, we know it must be positive, it's a length, I can multiply by x, no problem. So now I can say that 500 over pi, okay, must be greater than x squared. Okay, so therefore the square root, let me just carry on down here. Therefore we can say the square root of 500 over pi must be greater than x. So therefore x has to be greater than the square root of 500 over pi. So therefore x must be greater than 0. That's because of x, and because of y, okay, y must be greater than 0. If y must be greater than 0, this is the condition, x has to be greater than 500 over pi, because we replaced y with what x is in terms of y, and then we put that in the equality where that has to be greater than 0. So we've shown it. Okay, it's a bit of a strange question, but that's how you deal with it. So the next part of the question is going to ask us about minimums and maximums and whatnot. So what I'm going to do is I'm going to take, I think we're going to have to definitely use this, so I'll take this to the other page. Okay, so find the minimum perimeter of the pool, giving your answer correct to 3 significant figures. Now this is an important question, okay, and it's about minimums and maximums, and it applies also to graphs as well. So it's important. So we want to find the minimum perimeter of the pool, okay, and we're going to also justify that it's a minimum, okay, which is important. So the minimum value of a function is where it turns, the lowest value. You can also have a maximum value of a function is where it turns, okay. So that's why what I'm going to do is I'm going to find the turning point of the function here, okay, and then I'm going to prove that it's a minimum, which we really need to know how to do. So first thing I'm going to do is I'm going to find the differential, the gradient, because where it turns the gradient is 0. So I'm going to differentiate the function p with respect to x, okay. So before I can do that, actually I need to rewrite it so it's friendly for differentiating, preparing it for differentiating. So you got 2x plus 250. Now I don't want x in the denominator, so I'll write this as x to the power of minus 1 plus, and I'll write this as pi over 2 times x, just to make it separate from there. So when I differentiate 2x with respect to x, I get 2. When I differentiate 250 to the power of minus 1, 250x to the power of minus 1, I have to multiply by the minus 1, so I get minus 250. Then I have to take 1 away from the power, so I get to the power of minus 2. And then when I differentiate pi over 2 times x, the x disappears, I'm left with plus pi over 2. So I'm left with the differential, the gradient function is equal to 2 minus, let me rewrite this to make it easier to deal with, 250 over x squared plus pi over 2. Okay. Now, I know that at the minimum, okay, the differential, the gradient, dp dx must be equal to 0. So 2 minus 250 over x squared plus pi over 2 has to equal 0. Okay, so I'm going to multiply everything by, let me just do this, it's going to be easier. I have 2 plus pi over 2. Okay, so I'm actually going to make that into one fraction, that's easier. So on this side I'm going to have my 250 over x squared, just got rid of that. I'll make this into one fraction, so that's going to be 4 over 2 plus pi over 2, which is 4 plus pi over 2. Okay, so now I can rearrange this. So I can say x squared is equal to 500 over 4 plus pi. Okay, so x will be the square root of 500 over 4 plus pi. It doesn't say exact value, does it? Okay, so that's the value of x. I'll leave it like that because it's an exact value. Okay, so that's x at the turning point. Now I'm going to justify that it's a turning point. Okay, so I'm going to take this here. Oops, what did I do? I'm going to take this here. Okay, I'll write it down. So I'm going to take this, so it's 2p, it's dp dx is equal to 2 minus, I'll write it in this form so it's easy for me to differentiate again, plus pi over 2. Okay, to justify that it's a minimum or a maximum, what you have to do is you have to find the second differential. So that's, I've got to differentiate this again with respect to x. So when you differentiate, okay, dp dx with respect to x, you end up getting d squared p over dx squared. Okay, it's like dx squared, that's why it says it like that, because you're differentiating dp dx with respect to x. So that's going to give me, well, the constants are 2 and plus pi over 2, they disappear. I'm going to have minus 2 times minus 250, which is going to be positive 500, and I'll have x to the power of minus 3. Okay, so that's going to give me 500 over x cubed. Okay, and of course x is a positive value, so the value of x, the value of the second differential is going to be greater than 0, and if that's true, therefore it's a minimum. If the second differential was less than 0, it will be a maximum. Okay, because this is telling us that the gradient of the gradient, okay, is basically greater than 0. Okay, so the gradient of the gradient is greater than 0. So it means basically the gradient is increasing. So it's a minimum. Okay, the rate of change of the gradient is positive. So it's going to be increasing. So it's going from down to up. Okay, if the gradient was negative, if the gradient of the gradient was negative, the rate of change of the gradient was negative, it's going from positive to negative. The gradient is decreasing. It's going from positive to negative, so that would be a maximum. If the rate of change of the gradient is greater than 0, that means it's an increase. The gradient is increasing. The gradient is going from negative to positive, so it's a minimum. Okay, so that's the justification. You don't have to explain that, but just if you find the second differential is greater than 0 for the value of x that you have, you know it's a minimum. If the second differential is negative for the value of x you have, then it's going to be a maximum. So we know for sure this is a minimum. So we proved this is a minimum. Now we want to find the perimeter. Okay, so we actually have it here. Okay, so all we have to do now is substitute that value of x into this for the perimeter. Okay, so I've got this down here. Now the value of x we found was the square root of 500 over 4 plus pi. Okay, I'm just being a bit extra here, so I'll put 2 times the square root of 500 over 4 plus pi, okay, plus 250 divided by the square root of 500 over 4 plus pi, plus pi times pi over 2 times the square root of 500 over 4 plus pi. We could have just wrote it to maybe 4 or 5 decimal places and then continued, but I'm just being a bit extra. So we can say that the perimeter, because it asked us to find the minimum perimeter, yeah, so we've got to find the perimeter. So I'm going to put these, what I'm going to do is I'm going to take this, the square root of 500 over 4 plus pi, and I'm going to store that as a. Okay, And now I can just put that 2 times A. So 2, recall A, 2A plus, and I can have 250 divided by A. This is a nice thing about this store button. So recall A, okay, plus, and you're going to have pi over 2, pi over 2 times A. Okay, you can put times if you want. So that's 2 times root 500 over 4 plus pi, plus 250 divided by that, plus pi over 2 times that, and that gives me 59.756. So 59.756. And how do they tell us around it? To 3 significant figures. So that's going to be 59.8. 59.8 meters is our answer. And that's the end of that question.